So in this last part of the problem E09A, we're going to solve for v velocity components and then add them all up. So we have v1 equals minus delta psi 1 over delta x, which is minus delta per delta x of q1 over 2 pi arctangent of y minus a b1 divided by x minus a1, which is minus q1 over 2 pi. Again, the arctangent is 1 over 1 plus x, it's 1 plus y minus b1 squared over x minus a1 squared. And here we have minus y minus b1 over x minus a1 squared. So basically, derivative of 1 over x is minus 1 over x squared, and then derivative of the expression itself. So now these cancel out, and we end up, of course, here we would have, I can put it like this, we would have already x minus a1 squared to get the common denominator, to add 1 to this, so plus this. So basically we still get the proper result. We have minus times minus, so they cancel out. Q1 over 2 pi y minus b1 over x minus a1 squared plus y minus b1 squared. And now when we substitute the values, we have 2 over 2 pi, same values as before. This time around y is 0, b is minus 1, so 0 plus 1 over 1 minus 0 squared plus 0 plus 1 squared, which is 1 over 2 pi, gives us the same 0.159 meters per second. As I mentioned before, from the picture it is clear that due to source 1, u and v components are going to be the same because source is positioned at 45 degrees to the point of interest. Let's now do the v2. Again, it's the same expression as this one, only a1 and b1 become a2, b2, and q1 becomes q2, so we can immediately write, based on the line above, q2 over 2 pi y minus b2 x minus a2 squared plus y minus b2 squared equals 2 over pi, and now we have 0 plus 1 again, but below we have 1 minus 1 because now a2 is plus 1, and plus 0 plus 1 squared, which now becomes minus 1 over 2 pi equals to minus 0.159 meters per second. V3, due to vortex, we already know it is 0 because the vortex is positioned right above the point, but nevertheless, let's work it out. Minus delta psi 3 per delta x equals minus delta per delta x. In the exam, it would be enough that you just write due to position that it's going to be 0. That would be accepted. But now, so we have minus g3 over 2 pi ln of r3, which is x minus a3 squared plus y minus b3 squared. And this would be minus and minus cancel, so we have g3 over 2 pi. Again, we have expression down of x minus a3 squared plus b minus y minus b3 squared. And above we have 1 over 2 square root. I had a little more space now. Learn the lesson above. Plus y minus b3 squared times 2 times x minus a3. And again, this 2 and 2 cancel out, these two multiply, so the square root disappears. So we have v3 is equal to g3 over 2 pi times x minus a3 squared plus y minus b3 squared with x minus a3 in the numerator. So this is 1.5, that's the strength of the vortex, over 2 pi, and in numerator we have 1 and minus 1, 1 minus 1 squared plus 0 minus 1 squared. It's important to work out the denominator even though numerator is 0, because if I had 0 here for some reason, then I would have 0 over 0, so it's undefined. Here I have nicely basically 0 over 1, which is 0. So we add up now all of that. This is V, not R. V1 plus V2 plus V3, which is 0.159 meters per second plus, sorry, it's minus 0.159 meters per second plus 0 meters per second, which gives us 0. So all the V components cancel out. We have 2 of equal magnitude, and our complete velocity vector is now u times I plus v times j, which is 0.398 meters per second times I plus 0 meters per second times j. And that's the answer.